All right, guys, before you do this, please make sure you've tried them, and as you go through, really listen to the explanations. You guys are really hurting yourselves on these quizzes because I know we're just writing stuff down. We're trying to rush through it. We're not really listening to the explanations, some of us. And it's very obvious, obvious to those of us that are not doing well. We're just not getting the review and the practice that we need. All right, so without any more delay, we'll start getting into this. So we have a rectangular prism with a base, rectangular base. Obviously, the length is 25 and the width is 9. So volume equals base area times the height. That's for the rectangular prism. Then there's a second prism with a square base. So again, volume equals base area times the height for prisms. Okay. When it's a rectangle, it's length times width. Okay, length times width times height. And then for a square, it's just side times height, because it's still length times width, but the length and the width are equal. So you could just call it length times width again. All right, so we have 25 times 9 times the height of 12. Okay, and then this one we have 15 times 15 times some other height. We don't know. The volumes are equal, so I could set these equal to each other. All right, so it's going to be 2,000. This right here is 2,700 equals, and this is 225h. And then divide by 225. So 2,700 divided by 225. Just get your phone out, or if you don't have a calculator at home, turn it to the side, and you get scientific mode. You don't even need that for most of them, but anything with exponents you do. And then just, put everything in, make sure you're getting the right answers. You should get h equals 12. So it is choice 4. Choice 4. All right, so two prisms have equal heights. So now they have equal heights and equal volumes. The base of one is a pentagon, so we have a pentagonal prism. That's 5 sides. And the area of that base is 36. So capital B equals 36. The base area of the pentagonal prism is 36. And then there's the other one has a square base. And so if the heights and the volumes are both equal, okay, that means the base areas must be equal. All right? If the volumes and the heights are equal of two prisms, the base areas must also be equal. Why? Because it doesn't matter. It's volume equals base area times height. Volume equals base area times height. If the heights are equal and the volumes are equal, then the B's have to be equal. The capital B has to be equal. So they're both 36. So now answer the question. How many inches are in the length of each side of the square base? So I have a square, and I know my base area, my area of my square is 36. So what does it have to be? What times what? What times what will give me 36? 6 times 6 is 36. So 6 must be the side. So it's choice 2. What is the volume in cubic centimeters of a cylinder that has a height of 15 and a diameter of 12? Volume equals pi r squared h. It's on your formula sheet. Just make sure you know it's there. So it's pi, the radius is 6 squared, times the height, which is 15. And these are all in terms of pi, so I'm going to type this in my calculator. I'm not going to type the pi in. And that's going to give me 540 pi. That's choice 2. A right circular cylinder has a volume of 1,000 cubic inches and a height of 8. What is the radius? So again, same formula. I'm going to do it up here. I'm going to do it right here. Volume equals pi r squared h. Now they give me the volume. 1,000 equals pi. I don't know the radius, and then the height is 8. So it's 8 pi r squared. Got it? 8 pi r squared. 1,000 equals 8 pi, because the order doesn't matter. You're just multiplying. 8 pi r squared. So I'm going to divide by 8 pi. Okay, and then I'm left with r squared, so 1,000 over 8 pi equals r squared, and then of course you take the square root if you want to find r, because you have r squared. So you take the square root of 1,000 divided by 8 pi. Make sure the 8 pi goes in parentheses, guys. If you don't put it in parentheses, it's going to divide by 8 and then multiply by pi. It's not going to divide by the pi. So make sure you have that in parentheses. You should get 6.3. I did it ahead of time just to save us time, or this video would never end. The diameter of a sphere is 15 inches. What is the volume of the sphere? Okay, so volume equals 4/3 pi r cubed. It's pretty straightforward. Except diameter is 15, so radius is half of that, 7.5. So just type this in your calculator, 4/3 in parentheses times pi times 7.5 cubed. Get that calculator out. Go to your phone, go to your mom's phone, your dad's phone, whatever. Turn it to the side. It's scientific mode. Type it all in, multiplication. Make sure you're getting these because you're going to type it in wrong tomorrow. 1,767.1, bam, choice 3. A designer needs to create a perfectly circular necklaces. So circular necklaces have a, so we're creating these necklaces that have a radius of 10. What is the largest number of necklaces that can be made from the 1,000 centimeters of wire? So we have this long wire. We have this wire, right? And we want to see how many necklaces we can make. If you basically unravel the necklace, right? If you unravel the necklace, you're making a necklace out of just wire. It's long. Okay, it's just one long string. And then you make a circle, and then you got a necklace. Okay, so basically the distance around the circle is what we need to know. That's circumference. Okay, so circumference is 2 pi. I'm going to use radius, so 2 pi r. 2 pi r. 2 pi times 10. That's 20 pi. So the circumference of each necklace, all the way around the necklace, is 20 pi. There's 1,000 centimeters of wire, so if I divide 1,000 by 20 pi, again in parentheses, I get 15.9. So I can make 15.9 necklaces. So what happens is students pick 16. Well, that's not true. You don't have enough to make 16 necklaces. You're going to fall short. You almost get 16 necklaces. It says what is the largest number of necklaces that can be made. You can only make 15 necklaces. So that's tricky. And that's what they do on this exam. Got to read very careful. The Great Pyramid of Giza was constructed as a regular pyramid with a square base. So we have a square pyramid. It was built with approximately volume of 2,592,276 cubic meters and a height of 146. So they give us the height and they give us the volume. All right. What is the length of one side of its base? This is a tricky one. This is pretty involved. The formula for a pyramid, we should know, is the volume is 1/3 capital BH. So that means 1/3 base area times height. I know the volume, so it's 2,592,276 equals 1/3 B, I don't know B, and then the height is 146.5. So you want to solve for B, all right? You want to solve for B. So we're going to divide by 146.5. I know I'm going to run out of room here. And that's going to, I'm going to go up here now. That's going to give me a divide, when you divide that out, you get, I did it ahead of time, you get 17,694. And that equals, you shouldn't round it, but it doesn't matter because the choices are so far different. 17,694 equals, well, that's going to equal 1/3 B. And then times 3. That gets rid of the 1/3. So times 3. Capital B is going to equal this. 17,694 times 3, and that is 53084. 53084. Of course, it's not a choice because that's not what it's asking. It doesn't want the area of the base. It said what's one side of its base. So it's kind of similar to this one down here where we had the square base. The base area, guys, is 53,000. So I need to take the square root of that because it's, it's a square. So it's side times side. Okay, so I take the square root whenever I have a square, and that will give me, comes out to be 230 approximately. So 230 is the answer for that one. The cross section of a regular pyramid contains the altitude of the pyramid. So I have a regular pyramid. Doesn't matter what kind of pyramid. I'm just going to draw a rectangular pyramid, whatever. There's my pyramid. The cross section, that's a slice, contains the altitude. The altitude straight up and down. So basically they're slicing it right there. There's my slice. So if you can imagine a pyramid and slicing it this way, and you look at it, okay, what are you going to see? You're going to see a triangle. Because everything that makes up the triangle going up and down, or what makes up the pyramid going up and down, they're all triangles. It's a triangle. Every side of a pyramid is a triangle. The base might be a square. The base might be a rectangle. The base might be a triangle. The base might be a pentagon. We don't know. But up and down, you slice it that way, you're always going to get a triangle. You're always going to get a triangle. So that's going to be a 3. All right. Halfway there. If an equilateral triangle is continuously rotated around one of its medians, which three-dimensional object is generated? So I got to draw an equilateral triangle. Similar to the last one, kind of. Not really. It's continuously rotated around one of its medians. Remember, a median goes from the vertex to the midpoint. So here's a median. And we're going to rotate. There's a median right there. We're rotating around that. So if you spin around, round, remember we did those? Okay, spin, spin, spin. You spin a triangle basically around. What are you going to get? You're going to get a cone because it's going to create that circular bottom. All right, you're going to get a cone. Hemispherical water tank is filled with water and has a diameter of 10 feet. The water weighs 62.4 pounds per cubic foot. That's the density. Okay. Total weight of the full tank. All right, so here's the density. And I need the volume because density equals mass over volume. So if I want the mass, I want the total weight of the water in a full tank. So I want the total weight of the water, therefore I'm finding the mass. Okay, so I got the density, I want to find the volume. If I get the volume, I can find the mass. So volume equals, it's 4/3 pi r cubed. Got to use that reference sheet. 4/3 pi r cubed, but it's a hemisphere. So we're going to divide by 2. All right? Turn my page here. So it's going to be 4/3 times pi times the radius, which is 5 cubed, divide by 2. And that comes out to be 261.799. So that's my volume. Put that in here. So density is 62.4 equals mass over volume, 261.799. And then, of course, we cross multiply. So mass equals 62.4 times 261.799, 16,000. 16,336 is the, and that's going to be pounds. Okay, 16,336 pounds, and that is choice 2. Which equation represents a line that is perpendicular to the line represented here? All right, so 2x minus y equals 7. I need the slope. And remember, perpendicular lines have negative reciprocal slopes. Parallel lines have equal slopes. You got to know that. So I'm going to subtract 2x. I got to get y by itself. I can't tell the slope until I get y by itself. We've done this. We've done this. Divide by -1. So y equals, this is going to be positive 2x minus 7. So here's my line, and my slope is 2. If I want a perpendicular line, I need a perpendicular slope, which is going to be a negative reciprocal slope. The negative reciprocal slope is going to be -1/2, because I have 2, so the negative reciprocal is -1/2. Which one of these has a -1/2? That would be choice 3. So 11 is 3. We're getting there. 5 more, that's it. This one is involved. Now I'm going to start off by writing the formula, the slope. I'm going to put it up here. Y minus y1 equals m times x minus x1. That's the point slope formula. You got to make sure you know the point slope formula. The endpoints of the line segment, I'm going to draw it up here. The endpoints of the line segment, okay, ny. And then we want the perpendicular bisector, guys. The perpendicular bisector goes right through the midpoint, and it forms right angles. There it is. We're getting the equation of that thing right there. So we need the midpoint. You need the midpoint, and we need the slope, because perpendicular, negative reciprocal. Midpoint and slope. Okay? So midpoint, we just got to find out the middle. Pretty easy. A -11 and 5, the number that's right in the middle of -11 and 5 is -3. And in the middle of 5 and -7 is -1. Just figure out what number is right in the middle of those. Or take the average, right? -11 plus 5 divided by 2. -7 plus 5 divided by 2. All right? And that's how you get these. The slope is going to be the rise over run, or y2 minus y1 over x2 minus x1. So it's going to be 5 minus a -7. All right, that's going to be, so 5 minus -7 over -11 minus 5. So that's going to be 12 over -16, which is -3 over 4. Okay, so if the slope of this, if the slope of my segment is -3 over 4, the slope of my perpendicular bisector has to be the reciprocal and the negative of that. So the slope that I need is going to be 4/3. Now I'm going to use this formula, y minus y1, which is this, so y plus 1. And then I don't want -3/4, I want 4/3. And then x minus a -3, so x plus 3. So there is the equation of my perpendicular bisector. The midpoint is on the perpendicular bisector, and then you also have to have the negative reciprocal slope. The base of a pyramid is a rectangle with a width of 6 and a length of 8. Find in centimeters the height of the pyramid if the volume is 288. So volume equals base area times the height, 1/3, because it's a pyramid. The volume's 288. Okay, now since it's a rectangle base, we have a 6 and an 8. So the area, the capital B, is going to be 6 times 8, which is 48. So capital B is going to be 48. And then my height, I don't know. I'm trying to find the height. So a third of 48 is 16. This is 288 equals 16h, and then divide by 16. .288 divided by 16 is 18. As shown in the diagram below, they labeled everything. Find the nearest tenth. The distance from the wall to the base of the ladder. The wall, got to read carefully. Wall to the base of the ladder, right there. So there's my reference angle, guys. Okay, that's opposite. I'm not doing anything with that. This is adjacent. This is my hypotenuse. This is my opposite. I'm doing this and this. So it's adjacent over hypotenuse. SOHCAHTOA. Adjacent hypotenuse. I'm doing cosine. I'm going to do it over here just so you can see it. So I'm doing cos 65. It always goes cosine of the angle equals x over and then 5. And then you can cross multiply. 5 times the cosine of 65 is 2.1 to the nearest foot, so 2.1 feet. All right, 2 more and then we'll be done. Yay! A ship heading for the harbor. As the ship passes through point A, the navigator sights a lighthouse 10 degrees angle from the sight ahead. So that's going to be this guy right here, 10 degrees. The ship continues in a straight line for 5 miles. So this is 5 miles right here. It's going towards the lighthouse, so now it's going to point B. And at point B, the angle of elevation is 30 degrees. So that's this angle right there looking up at the lighthouse. How far is point B from the entrance of the harbor? So that's what we're trying to find. B to the harbor. And this is 90, okay, straight up and down. And we have enough information because I can find all the angles now. See these 2 angles here? Got to add up to 180, so this has to be 150. The 3 angles of the triangle have to add up to 180, so this has to be 20. 10, 20, and 150 is 180. And then 30 and 90 is 120, so this must be 60. So I got all my angles, which is awesome. So now I can either do law of sines twice or law of sines once, and then I can do either sine, cosine, or tangent. So law of sines over here, because I don't have a right angle. This triangle here, guys, this triangle over here is not a right triangle. If you don't have a right triangle, you can't do SOHCAHTOA. You can't do SOHCAHTOA if you don't have a right triangle. You can only do law of sines. So it's, remember, law of sines, A over the sine of A equals B over the sine of B. All right, so it's going to be 5 over the sine of its opposite angle, which is 20, equals, now we're going to call this Y. We're trying to find that shared side. Always find that shared side. Y, and then its opposite angle is 10. So Y over the sine of 10. So it's 5 over the sine of 20 equals Y over the sine of 10. Now you can cross multiply. 5 sine 10 equals Y sine 20. Divide by sine 20. And that comes out to be 2.53856.053. And you don't round that. So now over here, okay, I got 30 and I got my adjacent hypotenuse. So I could do cosine 30 equals x over y. But that's okay, I know y. I know my y. I can plug that in. So cosine 30 equals x over 2.5 blah 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 blah. That whole number there. I don't have any more room on. That's why I'm doing that. But you don't round it. Put that whole number there and then cross multiply. You're going to get x equals that times, so basically this times the cosine of 30, and that gives me 2.538 0.2 miles. Okay, so you should get 2.2 miles from point B to the entrance of the harbor. We are almost done. We got one more. So a water glass can be modeled by a truncated right cone. So that's what they do when they design water glasses. They use a cone and then they just chop off the bottom. All right. So let's see what's given here. The diameter of a top of a glass is 3 inches. So the diameter is 3. And the diameter of the bottom of the glass is 2 inches. So this is a diameter of 3. So my cone has a diameter of 3 at the top. And then the bottom of the glass has a diameter of 2, which means this cross section here, see how it's a slice, has a cross section of 2. So what that means is, see the two cones? We got the big cone, and then we got, oh, that's not where it is. And then we got this little cone here. Okay, that's what I'm trying to point out here. And then we have a height, and then we have a height. So that's what's happening in this problem. If this is a diameter of 2 and this is a diameter of 3, that means it's a 2 to 3 ratio. So the ratio is 2/3 from this cone to this cone. So if the height of the big cone, the height of the small cone is 10. The height of the glass is 5. The height of the glass is 5. That means from here to here is 5. And this to this is going to be double that because it's a 2 to 3 ratio. So there's 2. So you got here to here, and then you got, and that's 5. So here to here must be 5, and then here to here must be 5. So that's 5, and that's 5. That's kind of how I broke this down. So I'm kind of showing my work as to where it's coming from for part B, because part B wants you to find the height of the larger cone. So the smaller cone must have a height of 10. The larger cone has that 10, 5, 5, and 5. So the larger cone has a height of 15. I hope I'm explaining that well. And that's because it was a 2 to 3 ratio. It got sliced 2/3 of the way because I knew that base had a diameter of 2 compared to the top that had a diameter of 3. That's a 2 to 3 ratio. All right, so part A says the base with a diameter of 2 must be parallel to the base with a diameter of 3 in order to find the height. Why is that? Well, that's because of similar triangles. All right, so we'll just say, so part A, I'll put it up here. Part A is because triangles must be similar to form a ratio, a true ratio. Something like that. Or in order to write a proportion, I need to have similar triangles. So if you don't do parallel, you're not going to have similar triangles. So that's important for part A. Determine and state the nearest tenth of a cubic inch the volume of the water glass. So the volume of the water glass, we want the volume of the water glass, this right here, which is this right here. So basically what we want to do is take the here's the slice, right? We want to take the volume of the big cone and subtract the volume of the small cone, because see that'll leave the purple. That'll leave the purple. Take the whole volume, take away the white, you're going to be left with the purple. So we're subtracting the volumes of the cones. So it's going to be volume of the large cone minus the volume of the small cone. And they're both going to be 1/3 pi r squared h. That's the volume of a cone. So once you figure out what to do, the math is easy. All right, so it's going to be 1/3 pi. Now the radius of the smaller cone, the larger cone, it was 3 across, so the radius is 1.5. And then the height of the larger cone is 15. And then The radius of the smaller cone was 2, so it's 1. I'm sorry, the diameter was 2, so the radius is 1. And then the height of that smaller cone we said was 10. All right, so that's going to be, I did this, 35.34291,735. Take away 10.47197551, and you come up with 24.9 rounded to the nearest tenth. Always look to what they want it rounded to. 24.9. So that water cup must have a volume of 24.9 because I subtracted the big volume minus the small cone. Therefore, the leftover, this is the leftover piece right here. All right, so I will see you in class for the quiz. Hopefully you really listened and paid attention and got something out of this video to help you get a better grade tomorrow, because I really want to see those grades go up. See you then.